Would you agree that this triangular-shaped prism behaves the same way like this lens-shaped prism? Please stick around and we'll check it out. Today is the day to do some basic optics, some experimenting. Here you can see I have a laser pointer. This is the middle beam, and I have two other beams. They are on top and on the bottom in parallel. So this is representing a free beam. A free beam is a more or less parallel beam, and those are the outer ones. If I now take this bar-shaped prism and put it to the beams, what happens? Basically, nothing happens. The beams are passing through without any diffraction. But now if I tilt this bar a little bit, as you can see, the outgoing beams, they are still parallel to the incoming beams, but they are shifted in parallel. By the way, you can see some additional reflections. Those are due to a not existing anti-reflection coating. So now, what happens if I take this lens-shaped prism, if I put it here? Nothing too fancy, it's as we expected. There's a focus point where the beams are crossing. Now, in the beginning or in the intro, I said there's a similarity between this lens and this triangular shape. If I now put this triangular shape here, you can see there's also a crossing point. There's also kind of a focus point. So now let's go for some theory. Here on this whiteboard, there's a drawing, there's a sketch. And this is the optical axis, and on the upper part there's half of a lens form or a lens shape, and on the bottom part there's half of this triangular shape. If I take this orange beam here, it's a parallel beam, and we follow the beam where it is hitting the surface of the lens, and at this point, if I put there a tangent, due to the refractive index of the material, there's a diffraction or refraction, and this means the beam is crossing the optical axis at a certain point, the so-called focal point. If we now go to the other side with a triangular shape, this green beam, it's going to this surface of this prism, and if the angle is the same as the tangent on the lens-shaped side, this means there's a refraction and the beam is crossing as well at the focus point. Now, what's different if we go to another position or to another beam? For example, here, this parallel beam in orange, it's hitting a different point on the lens surface, and as it is roundish, there's a different angle for the tangent, and this means there's a different refraction. If we do the same for the prism part here, for the triangular part, yeah, there is no different angle at the hitting point. So this means the refraction is in a parallel way, so it doesn't hit the focus point. So this is kind of cheating when I said they are behaving the same, but it's, let's say, kind of similar. I hope you learned something today. If so, please leave a comment and see you in one of the next videos. Bye-bye.